Hello and welcome to our short demonstration on how to run FloEFD embedded in Solid Edge. FloEFD is the front-loading CFD solution that allows you to optimize a proposed design early on in the design phase when it's easier and less expensive to modify. In this case, we have a shell and tube heat exchanger, and in this demo we will investigate the influence of the baffles on the heat output. We start a project by using the FloEFD wizard. Here we set up the initial conditions for our project. We define a name for it, the basic unit system or modified units. In this example we enabled heat conduction in solids. Our default fluid is water and the default solid material is steel. Let's have a look at the first version without any baffles inside the shell. The flow conditions are defined in the boundary conditions. For the hot side we assigned an inlet volume flow rate of 50 cubic meters per hour at 120 degrees. On the opposite side, the outlet side, the static pressure is 1.6 bar at ambient temperature. For the cold side we applied 70 cubic meters per hour at 20 degrees Celsius and also 1.6 bar at the outlet. The applied goals are our physical parameters of interest. In this case we are particularly interested in the pressure losses and the enthalpy differences on both sides. For this purpose these four equation goals are used. Let's take a look at some of the results. We can create cut plots and we can let them move through the model automatically defined by the corresponding planes. The surface plots show the solid temperature on the tube surfaces. We used the flow trajectories to illustrate the flow in the hot side and in the cold side. We observe regions at low velocities and in addition we see a nearly parallel flow to the tubes. We can use the parametric study to produce operating diagrams. In this case the volume flow rate for the cold side is varied from 10 to 150 cubic meters per hour and the results can be used in Excel. And here we see the pressure drop and the enthalpy difference as a function of the flow rate. We use the clone function to set up a copy of our project. And we can activate the second configuration that contains some additional baffles to change the flow path through the side of the shell. The compare tool allows us to compare the results simultaneously, showing here the solid temperature on the tube surfaces, which seems to be more uniform for the version equipped with the baffles. These are the results of the two studies. The solid lines show the variant equipped with the baffles, the dashed lines show the variant without the baffles, and we can see that the variant equipped with the baffles has a higher thermal output but also a higher pressure drop. These investigations can be done very quickly with FloEFD embedded in Solid Edge.